Good day, my name is Madeline Asindino from the Group 5 of CPE 107L Section B2, and this is my lab vlog 5 where I will be answering question 2.2, which involves some analog temperature switches, encoder, and decoder. This vlog will be divided into 3 parts, and the first part will be the problem analysis because this is crucial in answering problems accurately, and especially where given a word problem. So the second part will be the encoder implementation in Logisim, and the part 3 will just be the decoder, also in Logisim. So for problem analysis, this is the question that was given to us. There are 4 given temperature values, and we are required to convert that into binary because it is stated here that it is a 2-bit encoder. So as for the decoder naman, the output should be the difference of the inputted temperature and 30, but we will just get the absolute value because it is stated here in the problem that there will be no negative difference. So as an example here, if I press temperature 15 Dao, the decoder value will be 15 because 30 minus 15 is 15, and so on and so forth. So as an overview lang, these are the 4 temperature values that was given: 40, 35, 28, and 15. So each of those values corresponds to a switch or a button, basta an analog signal. We will be creating an encoder to convert that signal into binary, and then we will convert that binary data or use that binary data for a decoder, which is actually the 7-segment display in question 2.1. So the part 3 of my vlog will be a merged effort of me and Miss Tariman, which is my group mate. So looking at the Excel file over here, we can see the truth table for the buttons or the switches with corresponding temperature values and also their output. So if the output is 0, 0, that means the input is 15. If the output is 0, 1, the input is 28. If the output is 1, 0, then the input is 35. If it's 1, 1, then the input is 40. So that is the conversion of the encoder that we are required to implement. So what else can we observe about switches or analog signals? We can see here that they supersede or they override all of those signals beneath them. They turn into don't care values because if you think of it logically, we cannot turn on both of the switches, magugulo yung circuit. So that means we can also simplify their Boolean expression into a max term. So, bakit? Kasi naka-OR na lang yung tig-dalawang switches to each other. So, we can write them in this manner. So, B1 over here, we can see that it may be turned on when C is turned on and D is also turned on. So, it is just C or D. So the same thing for B2. It is turned on when B and D, when B or D pala, are turned on. B or D. But we have a problem. We have C, we have B, we have D, but where is the input A? The input A is missing because there's no corresponding high signal here. But that is its definition. So, gagamitan na lang natin ng identity law. Anything that is ORed by itself is also itself. So, therefore, we just need to OR either one of these 2 Boolean expressions to a 0 value that includes A. So, paano natin masiset yung A as a 0 value na lang all the time? By ANDing it with a ground. So the ground is the additional component here in our circuit. Because if you think about it, if we AND A with a ground, even though we press A, it will never be true. So if it will never be true, then it will always be 0. And if that 0 is ORed with this, then the result will also be this, or C plus D lang. So we did not change anything in this expression, we just manipulated it to add the A input signal. So pwede rin dito sa B2 because they're the same lang naman, or expression. So we can now move on to the implementation of the encoder in Logisim now that we have these two simple Boolean expressions. So I've already prepared a circuit file which contains the three ICs that I will be using. We were asked by Ma'am Pellegrino to use ICs instead of gates, and these ICs are the ICs that we created in Log 1. So I will go ahead and add 4 buttons to represent the 4 temperature values that was given to us. Checks! Okay. False alarm daw. And so 15 to. This is 28. This is 35. And this is 40. Ay. Wala. Yan, 40. So, unahin ko na yung AND na naka-AND sa ground. Kasi yun yung pinaka-naalala ko. Yan. So, naka-AND siya sa ground. Yung input 15. Kawawa naman si input 15 grounded. So, next, naka-OR siya sa, let's go back, C or D. So, C or D, what is C? C. And C or D. C or D. Okay, so the output of this and the output of this are ORed to each other daw. So dito yan. And the output of that is actually B1. So let's label that B1. And for B2 naman, we have B ORed with D. So we have B ORed with D. So this output signal represents our B2. Let's label that B2. So let's see if our encoder works by testing the switches. Bakit yun? Parang dumikit ito. Wait lang. Parang dumikit siya dun sa 15 eh. Okay. So let's test out these switches. So this is 0, 0 now. That's their default values. So if I turn on 50, nothing should happen. Okay. If 28, dapat 0, 1. It works. If 35, dapat 1, 0. And if 40, dapat 1, 1. So we have now implemented the encoder in Logisim by using the shortcut or the simple Boolean expression by looking at these input signals as switches. Moving on to the part 3 of my Lab 5 vlog, I will now be implementing the decoder part of the problem, which is shown in this area, in Logisim. So we previously created an encoder which converts the 4 analog switch signals to binary. So the outputs that is encoded will be used for the 7-segment display. So we'll be using 2 LEDs for the 7-segment display because it is the difference of the temperature with 30, and some of their differences requires 2 digits. So we are gonna be using 2 7-segment display. So I will just be using this screen grab from Ma'am Pellegrina's circuit example, and this are the Boolean expression for the 4 inputs of our decoder, which was done in question 2.1. So for the first display, this display at the top, we can see that the first 3 inputs are grounded or connected to a ground, while the last input Z is A prime ANDed with B prime ORed with A and B. So for the second display here at the bottom, we can see that input W is also connected to the ground, while the X and the Z are connected to B prime. So I would just like to note that A represents the first bit and B represents the second bit, because we need to change the literal names so that we won't confuse it with the 4 input literals in our decoder. So for the Y, we have A prime B naman over here. So we will just be using this logic, except that instead of gates, we'll be using the ICs that we created from the previous vlog. So this is the previous Logisim circuit file, and now I will be adding an inverter because the Boolean expressions that we examined kanina have the complement form of these input signals, so we'll be needing an inverter. And then let's first mine the ground. So let's place the 2 decoders here now, and then let us first mine the ground. So since we already have a ground here for the previous encoder input 15, we can simply connect them to that ground nasa taas. So also this input W. Okay, then for the input Z for the first display, we have A prime ANDed with B prime ORed with A and B. So we will not be using additional ICs for that because we have free gates here from the encoder. So let's go ahead and implement that. Sa likod ko na lang padaanin para maluwag. Okay, then another one here, which will be the complement. Okay, next would be the normal inputs A and B. Okay, so their outputs are ORed together. And okay, so this is the input Z for the first display decoder. Okay, next would be the second display. We have B prime for X and Z. B prime is just this B prime. Okay, and we have A prime B for input Y. So A prime would be this signal, and B would be this signal. Okay, so this is input C. Okay, so we are done with the inputs of our decoder. Let us now place a 7-segment display here. One here and another one here. For the 7-segment display, the farthest one is this. Let's just confirm here. Okay. Oops. Then the next one would be from here. And the next one would be from here. And then this will be the farthest side. So we can see that it shows a 1, and let us hope that till the end the output is going to be correct. So I'll just again do the necessary connections for the other display here. Same process with the first display. It should form a number 5. This would be the farthest. Oops. Okay, so it's 15 because our encoder shows that the mode 00, and that indicates 15, diba? According to our problem. So if we press 15, nothing's going to happen. And in our 7-segment display, its output is correct because 30 minus 15 is 15. What about for the switch 28? Okay, we have 0, 1 in our encoder. And for a 7-segment display, we have 2 as the difference of 30 and 28. So next would be 35. So we have 1, 0 in our encoder. And our 7-segment display shows 5, which is the absolute value of 30 minus 35. And lastly, we have the switch 40. And in our encoder, we have 1, 1. And for our 7-segment display, we have 10 because 30 minus 40 is negative 10. So the absolute value of that is just positive 10. So now that we have confirmed that this circuit is working, we can now conclude that we have answered the problem. So that concludes my Lab 5 vlog, which is the temperature switch, encoder, and decoder. Thank you for watching!